This part of the training discusses enumeration methods. Enumeration methods process an array or collection of any kind of values or events. Enumeration methods operate on any expression or event property that returns one of the below values. An array, or an object implementing the collection interface, which is java.util.collection. The syntax is values expression.enumeration method method parameters. Optionally, the dot operator and additional enumeration methods as a chain. The enumeration method parameters are lambda expressions. We'll explain lambda expressions on the next few slides. We present the principles of enumeration methods here but won't discuss each method in detail. Enumeration methods are stateless. All methods are stateless. Enumeration methods compute a result as they execute. Enumeration methods don't incrementally update like aggregation functions. They are a convenient, easy to read and powerful way to express operations on arrays or collections. But, be mindful of performance, when frequently executing enumeration methods on large arrays or collections. Instead, aggregations, tables and indexes offer a way to organize data so there is no need to recompute. Contexts, discussed later, can partition and thus reduce the amount of input. The runtime allows configuring execution result caching. A lambda expression is a short block of code which takes in parameters and returns a value. The parameters to enumeration methods are often lambda expressions. The syntax has an arrow, either dash greater or equals greater. The arrow reads as goes to. The syntax differs whether there is a single parameter or multiple parameters. The syntax for a single parameter is lambda param goes to lambda expression. For instance, curly braces 1, 2, 3 dot, where parenthesis v goes to v not equals 2. This expression returns the values 1 and 3. The syntax for multiple parameters requires parenthesis. Parenthesis lambda param. Optionally, more lambda param goes to lambda expression. For instance, curly braces 1, 2, 3 dot, where parenthesis v index size goes to v equals 2 or index equals size minus 1. This expression returns the values 2 and 3. The following slides apply the where enumeration method for explanations. The where enumeration method filters elements. It takes a predicate expression as the single parameter. The predicate expression must return a Boolean value. The runtime evaluates the predicate expression for each element. Consider the expression curly braces 1, 2, 3 dot, where parenthesis v goes to v not equals 2. This expression returns the values 1 and 3. The explanation is the curly braces 1, 2, 3 returns an array of integer. The where enumeration method iterates the elements for each element. First, it assigns v to be the element value. Second, it evaluates v not equals 2. Third, in case the result is true, it adds the value to the resulting value collection. The where enumeration method, and many other methods, can have multiple lambda parameters. The first parameter is the value of the element and its type is the same type as the element type, named v in below example. The second parameter is the index of the element and its type is always integer, named index and below example. The third parameter is the size of the input array or collection and its type is always integer, named size and below example. For example, the expression curly braces 1, 2, 3 dot, where parenthesis v, index, size goes to v not equals 2 or index equals size minus 1. The result are the values 1 and 3. See step by step on the next slide. Since the input is an array of integer, the types for v, index and size are all integer. The compiler, as always, validates all expressions including lambda expressions. This is a step-by-step for the expression from the previous slide. The input is an array of integer equivalent to new int array curly braces 1, 2, 3. The lambda param names are v, index and size, but could be named anything. The lambda expression is v not equals 2 or index equals size minus 1. The step-by-step is: first, take element with value 1 from array. Set v equals 1 and index equals 0 and size equals 3. Evaluate lambda expression. This evaluates to true, therefore adding the value 1 to the result. Second, take element with value 2 from array. Set v equals 2 and index equals 1 and size equals 3. Evaluate lambda expression. This evaluates to false, do the next element. Third, take element with value 3 from array. Set v equals 3 and index equals 2 and size equals 3. Evaluate lambda expression. This evaluates to true, therefore adding the value 3 to the result. The expression returns the values 1 and 3. Use enumeration methods with event properties that are arrays, or collections of values or events. Values can be any type, the compiler supports all types. Parameterized types are supported. Define collection less string greater for a collection of string type values. Let's say there are coordinate and location event types as shown here. Create schema coordinate parenthesis xint, yint. Create schema location parenthesis location string, ID array and array, name list collection of string, coordinates coordinate array. The select has these expressions. ID array dot where parenthesis v goes to v greater 10. This outputs ID array values that are greater 10. Name list dot where parenthesis v goes to v equals quotes r0. This outputs nameless values that are r0. Coordinates dot where parenthesis v goes to v dot x equals 0 and v dot y equals 0. This outputs coordinate values that have 0 as x and y. This slide is about how to use enumeration methods with subqueries. For instance, this query considers the last location event per location. It outputs those that have the same ID array as the arriving location. Select parenthesis. Select star. From location. At unique parenthesis location. Dot where parenthesis. Lock goes to arriving. ID array equals lock. ID array. As same ID locations. From location. As arriving. The subquery is select star. From location. At unique parenthesis location. The subquery returns all the last location events unique by location. The where enumeration method evaluates each location event that the subquery returns. For each location event, the where method does this. Assign lock to be the location event. Evaluate arriving. ID array equals lock. ID array. When true, add the location event to the result. window, and sorted. Aggregation functions return events according to the group by clause, if provided. This example considers the last 10 seconds of withdrawal events for the same account ID as the current event. Output withdrawal events sorted by amount, but only those withdrawal events that have an amount that is at least 10 less than the current maximum amount for the account. Select sorted parenthesis amount. Where parenthesis WS goes to WS.amount less than max parenthesis WA.amount minus 10. From withdrawal. At time 10 seconds as WA. Group by account ID. The sorted amount aggregation function returns withdrawal events for the current account and sorted by amount. For each withdrawal event, the where method does this. Assign WS to be the withdrawal event. Evaluate WS.amount less than max parenthesis WA.amount minus 10. When true, add the withdrawal event to the result. Note the WA and WS for disambiguation of which amount is maxed. Other expressions returning arrays or collections of values or events are, typically, tables. A table expression can return all rows of a table and can return table aggregation columns. Named windows. A named window expression can return all or filtered events of a named window. The previous single row functions. Application-provided single row functions, user-defined functions, a script or an enum type. Variables. Variables can have an array type. A substitution parameter value provided by a prepared statement. In a match recognize pattern, a group variable. In a pattern, events collected in a repeat and a repeat until. A predicate expression is a condition that returns a Boolean value and that checks whether to include the value in results. The methods that take a predicate expression are: the anyOf method returns true when any element satisfies a condition. The allof method returns true when all elements satisfy a condition. The countof method returns the number of elements that satisfy a condition. The firstof method returns the first element that satisfies a condition. The lastof method returns the last element that satisfies a condition. The takewhile method returns elements from the start as long as a specified condition is true. The takewhilelast method returns elements from the end as long as a specified condition is true. The where method filters elements based on a predicate. Names are shown mixed case to make them easier to read but are not case sensitive. A value selector expression is an expression returning a new value of any type. The methods that take a value selector expression as a parameter are: the arrayof method returns an array of the elements. The average method computes the average of values. The minute and max methods return the minimum or maximum value. The min by and max by methods return the element that provides the minimum or maximum value. The most frequent and least frequent methods returns the most or least frequent value. The sum of method computes the sum of values. The select from method transforms each element resulting in a collection of transformed elements. A key selector expression is an expression returning a key value. Methods that take a key selector expression as a parameter are: the distinct of methods returns distinct elements. The order by and order by DESC method sorts the elements. The group by method groups the elements into a map of key and collection of values. The toMap method returns a map of key and value. Some of the above additionally take a value selector expression. The methods that provide set logic are: the intersect method produces the set intersection of the two collections. The union method forms a union of the input elements with source elements. The except method produces the set difference of the two collections. The sequence equal method determines whether two collections are equal by comparing each element. Equality semantics apply. The aggregate method aggregates elements by using seed as an initial accumulator value and applying an accumulator expression.